Good morning, people. There, maybe it's because it's a little bit later in the week, but it's a little sparse, and there's a couple of speakers not here, so maybe we'll wait another couple minutes there.
Good morning.
Good morning.
Good morning, David.
Good. Does anyone know if Julius Sebastian? Her eyes this morning.
I don't know if you guys, but I did hear you get some talk about where David was drinking last night.
Good.
Well,
He uploaded his slides at 2:54 a.m. So
Yeah, I thought that-
So that means he must have been almost some level of sober at the time.
Yeah, hopefully, once it's put off, it is around 10 o'clock afternoon. Hopefully he continues to keep my advice.
Sometimes you need to, keep laying it on.
Sometimes he makes poor choices. That's great.
But I think when you met up for dinner at 10, that's it, like at 10 minutes before you go around. I thought the two of you would help.
We went out, no, we went out to dinner right after the fundraiser.
Oh, then, okay, because Julius texted me, and I thought it was texting at 10 here.
That's right.
It's funny, oh, I'm sorry.
Hi, Julius.
He's awake.
More important, he's alive.
isn't that a free run?
No.
Oh, it's only. Only the one.
okay. As we'll go ahead and get started here. This is the Babel or Babel working group, depending on what you feel like. I'm Donald Eastlake with Huawei, co-chair. Other co-chair, Russ White, is not here. We originally, I think, were scheduled yesterday so he was planning to be here, and he made arrangements to leave either this morning or last night, I'm not sure. So when we got rescheduled for today, he was not here. So I thought when I did. Well, why is that? Note well, probably you've seen this before, but you should read it. We're operating under the IETF IPR rules. If you make any contributions, including saying anything during the meeting, you need to declare any IPR you know about that hasn't already been declared. And there's a bunch of other stuff here too you should look at. So why wasn't this? Surely there's a mode of this where it will page. I thought that mode should be correct, next mode. Yeah. Oh, yes, right. Which is the, okay.
First you open it up, and then you just use the arrows and it works.
Okay. Okay. Thank you. Document reviews. People should review documents if they want their documents to be reviewed, and that's what improves the quality of documents is the reviews and hopefully the resolution of the comments that are made during the reviews. So it still isn't in a mode where it automatically goes from one screen to the next.
Press that square, you activate that,
Okay.
and then if you just do the arrows, it should. Don't scroll, just use the arrows.
I'm not sure what you mean. If you mean the four up, right, down, left, and right arrows, that's the only thing I've used. I haven't scrolled at all during this.
Yeah. And then,
I'm hitting the down arrow.
No, left and right.
Oh, left and right. Oh, left and right. Somehow that doesn't seem logical to me. But anyway, moving right along. Agenda. We have an agenda. So we should bash on it if anybody wants to make any change. The plan is talk a bit about our status of milestones and shares, which is, I think there's good news there. And then presentations on changes to Babel HMAC, RTT-based routing, the information model, and the Yang model. And we'll sort of wrap it all up. Anybody wish to make any changes? Yeah.
Well, just one note, the model is, the Yang model is now a work group document. So it's published as
yes, it's, sorry, excuse me, I've fricked it everywhere else, I'm pretty sure. Not too surprisingly, I do the slides for each meeting by editing the slides for the previous meeting, and I failed to change it here. It's draft IETF Babel Yang model. It is a working group draft. Okay, no requests for changes. So we're now, that's right there. Document status. So we actually have a nifty, kind of like sort of cohesive set of 4 documents with publication requested. The applicability, the 2 security drafts, TTLS and HVAC, and RFC 6126 BIS. So seems hopefully that package will advance. We do have 3 working group drafts, including draft IETF Babel Yang model, which is correct here. The source specific and information model drafts, which are in working group last call. Other related drafts, there's the HomeNet Babel profile, which is in the RFC editor's queue in misref state, means it's waiting on normative references. And the 2 normative references it's waiting on are RFC 6126 BIS and the source specific draft. And then there's the Douglas Babel RTT extension draft. And this slide also shows the previous set of 3 experimental drafts. So we just moved the milestone of submission of RFC 6126 bis to the IESG, or actually to our AD, to be more specific, from the to be done to the current ones. We're, kind of behind relative to the actual dates on the current milestones, but we are making progress, I believe, on all fronts here. The management draft, the last one, is intended to refer to the Yang draft, in my opinion. So that's kind of the status of things. I think I'll wait till after the presentations, or there were a couple of working group actions concerning adoption and last call that I said would go through this meeting, but I think I'll do things related to those at the end of the meeting. So any questions or comments on that? I guess not. Then we will proceed with the agenda and with Julia's presentations. Let's see. So how do I? Actually, how do I get to the next thing here? Yeah.
So you're unit for the,
That's the. That's not what I want particularly. Hello? Why can't I? Oh, I see. This is taking a while. Okay. 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 And would you like a control device?
Can you do it for me?
I can do it for you.
That's great. So hello, I'm Julius Krabacek, and this thing over there is my name. And if you ever wonder why I have so many Z and strange consonants, that's because it's written in the Polish spelling system, which dates from the Middle Ages. Now the Czechs over here used to have a very similar writing system, but then in the early 17th century, there was a great reformer called Jan Hus, who redesigned the writing system to make it sensible. So if you ever look at my name, please use it as a cautionary tale about what happens when you come to IETF with an already deployed protocol and are too concerned about backwards compatibility. Next, please. Okay, so last summer, together with Klara Duch, who I think is online, and Weronika Kołodziejak, we set about to design a authentication mechanism for Babel that would be as simple and as comprehensible as possible. So I know nothing about cryptography, and the design criterion was something that I could understand. Okay, that means no DTLS, no complicated libraries whose security properties are difficult to understand and require some knowledge. And so it ended up being based on the work on a number of people. So it was based on some work that had been done by Denis Owsienko in RFC 7298. And we had a lot of input, and in particular, so I've tried to be exhaustive in the acknowledgements, but so here I will only mention Marcus Stenberg, who gave us some very important ideas. It has some properties, and we ended up, we did the opposite of what happens usually. Usually you have ambitious plans, and you end up realizing it's difficult, and so you scale them down. And in this case, actually, we were expecting to do less, and it turned out pretty well. We got a protocol that protects both unicast and multicast. So remember that in Babel, you have both unicast and multicast packets depending on various details of the protocol. It's not vulnerable to replay. It's reasonably easy to implement. It's been actually re-implemented by Toki, and the properties that make it easy to implement are that we don't require a global clock, there is no global counter in the network, and there is no persistent storage. So Barbara was telling me at the time, well, why are you trying to avoid persistent storage? There's no such thing as a router with no persistent storage. Well, the problem is that persistent storage is very difficult to do right. Okay, depending on the hardware you're on, you might have a hard disk, you might have an SSD, you might have some proprietary NVRAM, and trying to access it transactionally is going to be very difficult. So I've preferred to sweep the problem out under the rug by not assuming any persistent storage. It has algorithm agility. There are a few parameters you can change depending on what your needs are. Next, please. And what we did was that we did everything on the mailing list because I didn't feel competent. So the two ladies are cryptography students. They understand cryptography. They didn't necessarily understand routing protocols at the time. As to myself, I knew absolutely nothing about cryptography. And so we did everything in the open on the mailing list, except for two things that were done more recently and that I'm going to tell you about, which were mentioned on the mailing list, but didn't really have a lot of discussion. I hope they will be non-controversial. We changed the mandatory to implement MAC algorithms. So now what it says is that you must implement SHA-256 and you should implement Blake2S. And there is an additional requirement. You must discard your per neighbor cryptographic state after a bounded amount of time. Next, please. So the original RFC 729 done by Dennis had two mandatory to implement algorithms. They were SHA-1 and RIPE-MD 160. Now, I think that's fine, but I was told that SHA-1 is not recommended in new protocols. And one person who does understand cryptography told me that RIPE-MD 160 is somewhat niche. So in the latest version of the draft, we say that you must implement SHA-256, you should implement Blake2S, and the intent is that those are both must, except that you've written should in the draft in case you have some very good reason not to implement Blake2S. If you have no good reason to implement Blake2S, please implement both, and we implement both in both Babel D and Bird. Next, please. Look, I'll tell you the whole truth. The hash function just doesn't matter. So first of all, we're only using the hash function for authentication. So if there is a first pre-image attack, that's something difficult. I'm not sure what it is, but I'm told it's something difficult. Then we are threatened. But we are not threatened by collision attacks. If somebody manages to do a collision attack, then we are not threatened by that. So any hash function you may conceive for is strong enough. According to my computations, and I'm not a cryptographer, but according to my back-of-the-envelope computations, MD5 would be strong enough. MD4 is too weak. Okay, so anything you use reasonably, if you have a reasonable rekeying interval, will be strong enough. And you're only hashing the control packets. So unless you're running Babel on an abacus, then any hash function will be fast enough. So really, it doesn't matter. SHA-256 is clearly overkill for what we are doing, but even that will be fast enough. So it's fine. Next, please. However, some people are concerned about slow software routers, like the things you get in your home, with no hardware assist for SHA-256. And Toki and Dave suggested Blake2S. So I've done my homework. I've tried to find out what is about Blake2S. Actually, I asked Paul Rosier, to whom I'm grateful, to do my homework for me. And what Paul has been telling me is that it's blazingly fast in software. It has 128-bit length. It integrates keying, so you don't need to hash over the result of hashing because the keying is integrated in the protocol. You don't need the HMAC construction. And the issue with it, which is the reason why it was rejected as SHA-3, is that it's based on very similar principles as SHA-256. And so if SHA-256 is broken, most probably Blake2S will be broken too, which should not be a problem for us, because even if it's broken, it will still be strong enough for our needs. Next, please. Okay, so that's the first thing, the change in the mandatory to implement hash algorithm. The other change is that we've added some protection against delayed packets. So Babel HMAC is invulnerable to replay. If a packet has been used once, you will not manage to use the same packet again. It's also invulnerable to reordering. What it is vulnerable to is packets being delayed. So if a packet is in the right order, it can be delayed by arbitrary amounts of time. Now, if the attacker is at a network switch, it might be able to block packets and then send them later. We don't know any attack that could be against Babel that could be using delayed packets, but the notion that there are packets that have been sent, authenticated, and they are replayed, and they are intercepted, and then sent, say, 2 hours later, is something that makes us nervous. So we've added, next please, excuse me. So one property of the protocol is that a node may, at any time, discard its per-peer cryptographic state. Okay, so you can say, okay, forget anything about the exchange I've made with a given peer, and then there is a mechanism called the challenge mechanism that will create a new cryptographic state at the cost of 1 RTT of lost packets. And the node can do that at any time. And what we've added is that now a node must discard its cryptographic state after a bounded time with no correctly authenticated packet. Okay, so we don't give any figures for the bound. We say you must ensure that there is a bound on the time on which you keep cryptographic state for somebody who's not speaking to you. Okay, and we are not specifying the mechanism, but we do give implementation advice. Next, please. So we've made 2 non-controversial changes to the protocol, and I've described them in this talk. Thank you for your attention.
Michael Abrams, just a clarification. So you're doing this as an offset in time from now, and they don't have to have synchronized clocks at all. There is no requirement for the different devices to agree on what time
None
it is.
at all.
Okay, good.
So we have surprisingly weak requirements. I'm still surprised we managed to do that. And if you're wondering where the catch is, there's overhead in the packet. There is basically that costs us 8 bytes per packet of overhead.
Yeah, just that's a typical thing that cryptography people might realize, that a lot of these things don't have a real-time clock that is battery backed up, and they might come up with any time whatsoever, and I see this all the time.
I might mention that this ability to discard the cryptographic state seems really good, because that might happen like because you crashed or something. So you know. Any other questions or comments on this presentation? Let's see. So if I go, how do I get to the? Good. Okay. The next one is delay-based routing. Go ahead.
Okay, hello. I'm Julius Krobachek. Did I mention the spelling of my name? Next, please. So I'd like to tell you, when you grow really old, you start taking the things you did when you were young and trying to recycle them. And so today I'm going to tell you about something we did 4 years ago and that I've just asked for adoption by this working group. Now, and that's joint work with Baptiste Jongles. So there's a company in Paris, they're called Nexedi, and Nexedi are running a distributed cloud system. So they have data centers all over the place. And what they are trying to do is to build a distributed cloud out of all of those data centers. And their original plan was to run over the public IPv6 infrastructure. And that failed horribly. The problem is that the public IPv6 infrastructure is not reliable enough. And if you have enough nodes, then the probability that anyone can speak to anyone else is basically 0. And so they came up to me, and I said, well, why don't you put a bunch of tunnels and run some dynamic routing protocol over the tunnels? Okay, so we designed over a restaurant napkin an algorithm that would allow us to have enough tunnels so that the network remains connected. And then they told me, okay, but what routing protocol shall we use? Okay, I said it doesn't matter. It doesn't matter because since you've separated the tunneling bit from the routing bit, you'll be able to change in the future. So why don't you try Babel? They said, cool. And for 8 years now, they have been running Babel, and they've had very good experiences with them. And they started with normal unextended Babel, and they were very happy as long as all of their data centers were in France. And one day, they set up a new data center in Tokyo. So here's an example topology, and that's an actual problem that they saw. So that's a little bit an opposite of HMAC. HMAC is something that we did because we wanted to do something clean. Here, we were trying to solve an actual problem that real people had. And in this topology, what happens when the Lille-Marseille link breaks? The tunnel has broken for some reason because some ISP has decided that it's cheaper to break connectivity and violate their SLA rather than pay for transit. And you have no connectivity between Lille and Marseille. Well, Babel sees 2 hops through Paris and 2 hops through Tokyo. And so non-deterministically, 1/2 of the time, it will decide to route the packet from Lille to Marseille through Tokyo. We have nothing against Tokyo, but clearly routing packets from Lille to Marseille through Tokyo is a bad idea. Next, please. So my first suggestion was, why don't you put a GPS in every router? And then we can use the geographical distance for breaking ties in our routing. And they said, that's out of the question. That's out of the question. And what they told me was that the problem was not the price of the GPS. The problem is the human being who is going to make sure that all of those GPS are running at any given time. So you're introducing too much failure modes. You're introducing unusual things in the data center. They said that's out of the question. So we decided to measure the two-way delay, the RTT, and derive a metric from that. So before somebody comes up and tells me about TCP Vegas or LEDBAT or BBR, or is it BRR? BBR. Okay, all of those things that measure one-way delay. I know it's possible to measure one-way delay, but it's more fragile than RTT, and it's more difficult to implement. And remember that here we're not doing a congestion control algorithm. What we're doing here is a routing protocol. The goal of the routing protocol is to select the best route. So you're not required to accurately model reality. As long as you've managed to find the best route, you've won, even if your modeling of reality is somewhat coarse. And RTT appears to be good enough, at least for this application. And the problem is that the natural way to measure RTT, basically ping, requires asymmetric, there's a client and a server, and synchronous interaction. You have to answer the ping as fast as possible. Now, Babel is a symmetric protocol, and it's an asynchronous protocol. Nowhere in Babel does it say you have to reply straight away. There are times where it says you must send a packet in a timely manner, but at no point do you have to react immediately. And the other problem is that using RTT as input to a routing metric causes a negative feedback loop, which I'm going to describe, which might lead to persistent oscillations. Next, please. So RTT is, on this diagram, the distance between T0 and T. And the natural way of measuring it is to send a packet from a client to a server and have the server reply as quickly as possible. So first, that's asymmetric. That's something we could work around. Actually, there's no big deal with doing asymmetric stuff within Babel. But the other problem is that when the server replies the ping, it must answer pong as quickly as possible. And the delay you have between the ping and the pong is what is going to kill your accuracy. And now, because in Babel you're allowed to reply later, you might have buffered some stuff to be sent later. And here you have tricky issues of, do I flash everything right now and cause congestion? Do I reorder packets and cause pathology due to packet reordering? Okay, it looked like a little bit tricky to implement. Next, please. And so what we decided to do was to use Mills' algorithm. So Mills' algorithm was done by Mills, and it was originally implemented in Hello, which was the routing protocol used by the fuzzball, for people who still remember the fuzzball. So either people who are old enough to remember fuzzball, or people who, like me, enjoy doing protocol archaeology. And so there's actually a TLV in Babel that is named in the honor of the Hello routing protocol. And the same algorithm has been used later, still by Mills, in something that all of you are using, which is NTP. So the idea of Mills' algorithm is that you do a symmetric asynchronous ping. You send your packets at any time you want. And here I'm concentrating on the second packet, the one that goes at time TT from the right to the left. And this packet is not just a silly ping packet with no data. It contains 3 timestamps, which are TO, which is copied from the previous packet in the other direction, which is called the origin timestamp. TR, which is the time at which we received the previous packet, which is called the reference timestamp. And it also contains the transmit timestamp, which is the time we're sending this packet. Okay, and now be careful. TO and T are according to the left peer's clock, and TR, TT are according to the right peer's clock, and we don't assume that the clocks are synchronized. They might have an arbitrary offset between them. And then once the guy on the left receives the packet, it computes it, it timestamps it with T, the time at which it received it, and computes T minus TO, both times on the left, TT minus TR, both times on the right. Makes the difference between the two, and that gives you an estimate of the RTT. And that's symmetric, that's asynchronous, that doesn't require clocks to be synchronized, and the reasons, on the other hand, are something you must do. You must compute the timestamp at which you send the packet, the TT, as late as possible, just before you send the packet, not when you buffer it. And same thing, as soon as you receive a packet, before you even parse it, you timestamp it. And that's what your accuracy is going to depend on. Next, please. So we wanted to do Mills' algorithm in Babel, and what we've done was to encode the timestamps and sub-TLVs. And the transmission timestamp, so the time at which the packet is sent, that's a property of the packet. So we've put it in the hello, and that may have been a mistake. Perhaps it should have been simply a TLV rather than a sub-TLV of hello. And the other property, and the other 2 timestamps, the origin and reference, those are copied from the latest packet you received from the peer. So they are specific to a given peer, and they are sold as sub-TLVs of the IHU TLV. And originally we started with a 10 millisecond granularity, and then Dave told us what he thought about it. You know Dave? You know how he tells you that he disagrees like 7 times in a row. Okay, until you get it. And I wasn't sure, but my co-author Baptiste said, look, he's absolutely right. It costs us 4 extra bytes, and we never know when the extra precision might come out to be useful. And so the granularity is 1 microsecond. Next, please. Okay, no secrets here. 32 bits rolls around every 36 years, or is it 72? I'm not sure with the sign, but okay, no particular issues here. Next, please. Okay, so Mills' algorithm is going to give you some RTT samples. And that's a noisy signal and a signal that is not immediately useful for a routing metric. Remember, we're doing a routing protocol here. Anything that's not about selecting the right route is just noise. We're not in, yeah?
I'm a bit slow here. Michael Abramson again. You said microseconds, so you're counting microseconds. So you're 32-bit counter and you're counting microseconds.
No.
Okay, so what was the 32-bit?
I said something stupid about the year, about rolling over.
Yes.
I did. I was completely wrong.
Right. So
It rolls over much
you
quicker.
have two raised to the 32 microseconds that
That's
you
right.
can use.
And
Okay.
that would be 32,000 seconds.
So it's 4 billion
It's
divided
it's
by
a few
1 million
hours.
is 4,000 seconds. So it should be
Yeah, it's an
upper
hour.
bound. That-
It's an hour. I'm
so this is
completely
of
off.
course, unless you're going interplanetary.
Well, I'd suggest we tackle this problem when we have it.
I'm not.
Yeah, sure. Yeah, sure. I was completely off. Yeah. So we are assuming here that you send at least a hello every hour. Okay, so you get a bunch, some noisy signal, but your goal is to select the routes. Okay, and you need to do quite a bit of processing. So the RTT samples that you get are a noisy signal. You do some basic smoothing over there, then that gives you the smoothed RTT. And the RTT is a time in milliseconds. That's not a metric. In order to get a metric, you have to map it to the abstract units that we use for our metrics. So you take your link cost, the normal link cost, which is the 96 that you have with normal Babel, and you compute a penalty from the smoothed RTT. And this penalty is not a linear map from the RTT. I'm going to explain how. You add the penalty to the link cost. From that, you derive a metric. And here, that's important, there's a third mechanism, which is a hysteresis that's applied to the metric. I'm going to describe all of that. Next, please. So the RTT samples we get are a noisy signal. So that's actual data from an actual tunnel between France and Japan, and that's the bad case. The good case is actually worse in some ways. That's the bad case at the time when the RTT was very noisy. So that's during the day. And what you see is that it oscillates widely between 280 and 320 milliseconds, and that you have a lot of outliers. And the blue line is the smoothed data, and the smooth data is a signal that you can actually use. So note the horizontal scale, that's 10 hours of sampling. And so what we do is, so I think that the actual algorithm you use for smoothing should not matter much. You just want a smooth signal, but we did not do any real evaluation of what happens when you change your smoothing algorithm. So we've just stolen the algorithm from TCP, the one that's used for computing the RTT in TCP, and the constant alpha, which TCP says should be between 0.8 and 0.9. We chose a 0.836. And first person who works out why, I'll be very impressed if you work out why. You won't work it out now. You will need at least an envelope. Next, please. You want the answer?
Yes.
It's easy to compute with integer arithmetic. We're doing Taylor's some stuff. That's the whole reason. Okay, now we have a smoothed RTT signal. But using RTT for computing a metric causes a feedback loop. You know, when you were a kid on the highway and it was really hot in the back of the car, and the highway was really congested. And then the radio would say, well, there's nobody on the other highway. And then everyone would move to the other highway, which would get congested. So the radio would say, hey, there's nobody on the first highway, and everyone would move back. What's going back on here is that there is a negative feedback loop. The more you push traffic over a route, the more its RTT increases. And therefore, the less desirable it becomes, and therefore the less traffic you push over it. Now, usually a negative loop, a negative feedback loop, is what you like, what converges, because the more you do something, the less you do it. But here we're in a discrete space. Either we go to the left or we go to the right. The fixed point doesn't actually exist, so you end up oscillating. Now, Babel doesn't care. Even in the presence of oscillations, Babel will push packets towards the destination according to loop-free paths. there's not much that can be wrong. But if you oscillate between routes, you might reorder packets. And higher layer protocols do actually care. So you need to limit the frequency of oscillations. Next, please. And the insight came from some old paper from the 1980s, which was trying to use RTT and link state protocols. And the answer is you want to saturate your metric. So instead of mapping RTT to a metric linearly, as you would expect, what you're doing is that you have a range below min RTT at which you consider, look, this route is good. This link is good. It doesn't matter how good it is. And above, and that's not important. The important bit is that above max RTT, you consider this link is bad. It's really bad. I don't want to use it if I have any choice. And at that point, the penalty remains constant. And the fact that at some point you stop penalizing high RTT links, that is what is going to limit your oscillations. And what you want is that this max RTT value is well chosen, and this part of the protocol requires manual tuning. Next, please. Now, the saturation bit avoids oscillating between congested links, but you might still, if you're in the intermediate range, have two routes that have very similar RTT, and they are oscillating around a value, and you will end up switching. So I want to apply hysteresis, and there are many hysteresis algorithms, so I worked out this one. So in this one, you have MA, which is the metric that's actually announced. And there is a second metric, which I call the smooth metric, which is basically an exponential average, a smooth version of the announced metric. So think of MA as being the short-term metric. It tells you how good the route is right now, and MS being a history-sensitive metric, it tells you how good this route has been recently. And when you switch routes, you only switch routes if the new route is better than the old route, both short-term and long-term. And this asymmetry between better and worse is what is going to give you hysteresis and hence more stability. Next, please. That's with hysteresis and no smoothing. Is Dave online? The pity. So this is worst case. We constructed a diamond topology in simulation with huge amounts of buffer bloat. So buffer bloat is really bad for us because it means that the RTTs vary very widely with nothing to break the feedback loop. So those are 4 bloated routers in a diamond topology measured over 4,500 seconds. Michael, help me because I'll say something stupid again. That would be about an hour and a half.
Yes.
And what you can see is that you have oscillations between the red route and the green route. So you have to look carefully at the frequency. Next, please. And now you add you tune the metric to have a max RTT value that is well chosen. It's the dashed blue line around 100 and something. So what you're doing is that the links are spending most of the time in their saturated state. And at this point, you pick a link, the RTT of the link increases because you have buffer bloat. So you switch to the other link, but the RTT of the original link will only decrease once the buffers have drained. And then you have the hysteresis that takes some time to take it into account and it's applied after saturation. And together, between the fact that you're waiting for the buffers to drain without measuring RTT because you're in the saturated range, plus the hysteresis bit, you end up having oscillations that are on the order of a minute.
But that does depend on Babel being scheduled along with the data, right? If you have like type of service prioritization of the routing protocol traffic, then this will not.
Then you have no problem.
Okay.
Then you're measuring the link RTT without measuring the RTT due to queuing, and all of those mechanisms are useless because you're not going to have the feedback loop.
So what he's also talking about running over tunnels, and you might not have the prioritization for the routing protocol when you're running over a tunnel over the internet. I think you're looking for to get the really, really worst scenario here. That's where you're trying to model there.
So I'll put it differently. Perhaps I wasn't sufficiently clear. We don't want this to happen. The feedback loop is a bad thing, and it doesn't happen in practice. In practice, you're going to have plenty of throughput. Okay, you're running over gigabit links. Okay, nobody has ever managed to use a whole gigabit except perhaps David, but even he, I'm not sure. Okay, Michael too.
Yes. So I just want to say about buffer bloat. I had to debloat our GigE bidirectional offering because when I ran iPerf, single TCP session, 100 milliseconds of buffer bloat if I did not debloat it. The standard config just asked the router to shape at 1 gigabit per second. Then the TCP guys have done a wonderful job, and TCP will take all the bandwidth and it'll use 100 milliseconds of buffering.
Yeah.
Right. So the one that came default in the Linux distributions that I was using did this. So this is not as silly as it might seem.
No, it's not silly. So basically, we're assuming that you run this.
Right. Okay. Pathological was probably the name, the word I was using for not silly, but
Yeah.
this can actually be a real problem.
No. What we want is a protocol that those mechanisms are not used when your network is working fine. What we don't want is a catastrophic mode of failure when your network happens to trigger this thing. Okay, ideally, of course, you don't get the feedback loop in the first place and you have no problem. Okay, is that, yeah, next please. Okay, I'll tell you the whole truth. We've done some really bad science. We wanted to have a solution that worked. We ended up, we had only a few months because that was a 5th-year internship, and we did not, at the time, work out a complete understanding of what's going on. We did an engineering job instead of doing a scientific job. That is, we did manage to get something that works beautifully and that has been working in production for 8 years now, but we did not actually study all the trade-offs and we don't fully understand what's going on. So there is one minor issue on the packet format, which is that the IHU sub-TLV can only be interpreted if the packet contains a hello. So remember, there are 3 timestamps, and 2 are carried by the IHU because they are per peer, and 1 is carried by the hello. So that means that in order to interpret the data in the IHU, you need to put a hello in every packet. So that requires some inter-TLV scheduling in Babel, and that's something I really dislike. So I've written an alternative here, which is to include a transmit timestamp in each IHU, but that causes a different problem. So remember that you are timestamping the packet as late as possible. So what we do is that when we buffer the IHU, the hello, we put a pad sub-TLV in it. And at the very last moment, we patch the hello with the timestamp. And that's fine because there is only 1 hello in the packet. But there are multiple IHUs. And if you need to patch it multiple times, the implementation will become more complex. The other alternative that I didn't write here and which I actually like more is to use the timestamp on the hello, to use the timestamp in a dedicated timestamp TLV rather than attaching it to the hello. That's something we will need to discuss. And we did some, yeah.
Michael Abrahamson, again, how often are the hellos typically sent? Is it every 10?
Every 4 seconds.
4 seconds.
By default. Okay, and the minimum value supported by the protocol is 10 milliseconds. And what we did is that we did do evaluating of the interesting bits, like why saturating is important, but there are some things that where we did not do our job at the end. We didn't evaluate what happens when you change smoothing functions. That's something that doesn't bother me much because the answer is pretty clear. Nothing much will happen because the smoothing is not important. Bad things happen in this protocol if max RTT is too large. If max RTT is too large, you get oscillations in the bad cases. And we didn't do any work on auto-tuning max RTT, which should be doable. And I think that's our greatest sin. We didn't fully evaluate the effect of hysteresis and how the hysteresis should be tuned. So it's obvious you need some form of hysteresis, but whether we've done the right thing, that's not clear at all. Next, please. And that is the reason why. So what we have here is something that works beautifully in production. We'd like to get it standardized. And the packet format, I think, is something that we understand. We understand the trade-offs. But in order to make use of it, you have to use a bunch of algorithms, and those algorithms are not fully understood. So what I would like to see would be a situation in which we manage to standardize the packet format, and in the normative part of the document, just say, hey, folks, that's how you measure RTT and Babel if you need RTT. And what you use this RTT for, I'd like to avoid standardizing, because I don't think we're ready to standardize that, and just have an informative appendix saying, look, that's what we've used it for. It works pretty well. Okay, you might take inspiration, and we would like to do more research about the algorithm, but of course no ETA for that, because there is always other stuff coming up. Thank you for your attention.
David Skenazy, Google. Thanks, Julius. First point, I'm really supportive of this work, and I do think it should happen here. I'm really glad that we have one actually deployed extension like this, which really reassures us that the extension mechanism in Babel works. So that's a great use case that we're shipping something that we know is solid. Now a question, have you, just out of curiosity, have you tried running this in Babel D, running both the RTT extension and HMAC, and how does that impact timing?
Oh, it doesn't work. It doesn't work due to a limitation of the implementation. So remember that in order to make this work, you need to have a hello together with every IHU. So the timestamp will be ignored if an IHU is spent in a packet that doesn't have a hello. Now remember that with DTLS, HMAC, no, with HMAC we haven't. With DTLS it doesn't work, with HMAC we haven't. We haven't done any testing. There's no reason it shouldn't work. No incompatibility with HMAC. And
it might impact the timing.
It might impact the timing, but that's just one pass of hashing over the packet. But that's a good experiment to do, yeah.
And so it might be worth just adding somewhere in the document that it doesn't work with DTLS and saying why. Because I think that's an acceptable.
No, that's the implementation. That's the implementation. That's not the protocol, because nothing prevents you.
Oh, yeah, unicast hellos.
So there are two things. You have unicast hellos and you have unscheduled hellos. So you don't even need to do anything complicated. You have the unscheduled hellos. So now it can work with DTLS over unicast.
Cool. Like maybe explaining how to do that could be a nice appendix or something.
I'd rather we didn't explain it until we did it.
Are there any other comments or questions? So there's a call for working group adoption was posted, which ends at this meeting, and there's been strong support on the mailing list and no opposition. Is there anybody in the room that's opposed to adopting this as a working group draft? Hearing nobody, it is so adopted, and I'll ask the authors to post the 0.0 version as a working group draft.
Thank you very much.
Is there anybody who would be willing to write quick notes for an upload? You can do it. Oh, it's on you.
By the way, if there's, is there anybody who hasn't signed the blue sheets, and maybe they could put their hand up and we could get the blue sheets to them, but maybe everybody has signed the blue sheets, so I would.
And then the button,
You have to do this one too?
yeah, the magic button.
Ah, okay. They don't have boxes, they have X's. These are.
Okay, So the information model. It is in WGLC, which means,
Oh, sorry. I'm screwing up. Okay.
Donald, you're as bad as Aaron. Oh my God. In the Pechacucha, Aaron was like forwarding my slides before I was done with my 20 seconds, and it was so wrong. Okay.
I just got in the habit with Julius's presentation where I had to advance the slides.
All right, you now get 20 seconds per slide.
Okay, so anyway, we have been, Mahesh and I have had a great discussion, at least I think so. I don't know how Mahesh feels about it. And we've been doing it over on GitHub, in my GitHub site where I've been trying to keep editors' drafts and things like that. I have not put, I know I promised I would, I have not put the updated broadband forum data model there. I just sort of ran out of time with everything else I was doing this week. But it's in good shape. I had great comments out of broadband forum as well. So, major changes. Clearly, we did some stuff on HMAC, some stuff on DTLS. I put in the statistics and message that we agreed to coming out of Bangkok, and there was also some additional discussion on the list that helped me clarify some stuff. I thought that was great, and the other stuff out of Bangkok I did. Okay, so I've got the rest of the slides are about some issues I would really like to get some input on. Number one. Do we have the link types registry? Do we have the right names currently in the registry? And is it meaningful to describe what sorts of links it is used for? And is there any idea on how extensive the list should be? Now, Julius has previously said, this is, I think, you really only want the main four, and then we can leave some room for experimental stuff at this time if they want it. Mahesh and I have discussed that, in fact, now that we understand better that Ethernet isn't really just Ethernet, but it supposedly incorporates everything that's wired, including all of the no new wire protocols like Powerline and Mocha and things like that. We're really confused and wondering if we should change it back to wired or Julius.
So if you look at the Babel implementation, you're going to have a lot of per-link tweaks. Are you going to use packet loss for computing the metric? Are you going to use RTT for computing the metric? Are you going to use split horizon and so on? That's impossible for a normal human being to tune. And because of that, we have bundled sets of parameters into names that you can give to the actual users who don't want to understand all of the details. So for example, wired means no link quality estimation, no RTT, and use split horizon. Okay. I'm not very keen on inserting things that don't have clear mappings onto the algorithm used by Babel.
So, Michael Abrams, so instead of inferring these properties, don't you want to model those properties instead? Instead of trying to create, is this going to be used for that? Don't you want to? There is an IANA link type list, FTDI and blah, blah, blah. But if we're modeling properties here, shouldn't we put the properties in here instead of having, Ethernet and mean something?
So, in other words, maybe under the used for links defined by, describe the properties of the links that you use these names for. Okay.
I mean, if this is the reason why we're saying Ethernet is because there are Babel properties, then put the properties in there instead of making up something and inferring from it.
Okay.
So basically the question is, do we want to be exporting something that makes sense, or do we want to be exporting something that the users have a chance of understanding? And that's a difficult call.
No, I think we can meet both. Actually, what I'm hearing is we should not use the term Ethernet. That's really confusing. the description should be really about the properties of the types of links. And this should be, I don't know, maybe the names can be more esoteric to meet the description or to characterize the grouping of link characteristics.
Benedict Wong. I would agree with that in that for wireless, maybe, I'm not sure whether Babel is considered over cellular networks, but the RSSI kind of thing for the standard Wi-Fi and over a cellular network will be very, very different.
Okay, I think I've got a way forward on this and I understand better, and we may actually change this from a link type to a link properties type, just so that we get it completely out of the people who are thinking of the IANA IF list. Yeah? Cool. I hope you got that on the notes. Oh my God. Well, hopefully, you know, the Meet Echo recording will work. Okay. HMAC DTLS interfaces modeling. Had some discussion of additive interfaces. Oh, good. Michael's leaving us. Okay.
You just said 1 hour, so I made it 1 hour.
Nobody said 1 hour. Go away. Okay. Now, Mahesh and I were discussing, and actually I got some input in broadband form that we should actually change the direction of the reference. Right now I was trying to reference two interfaces from HMAC and DTLS, but it's been suggested that it might really solve a whole lot of issues if we change the direction and from interfaces reference the HMAC and DTLS objects, and that would actually match more closely with what Julius was describing on the list as to what you were doing. If we do this, I still need to consider where to put the global DTLS and HMAC parameters in this decision, because I'm pretty sure that like the use of the cached info extension, we don't want that to be kind of a per interface decision. But maybe I don't know, and that would be a useful thing to get feedback on, similar to the server certificate type extension. And those are the DTLS things. And then on the HMAC side, we've got whether the verification of received packets is enabled. And the question is, you know, if we move the direction of linkage, should these things be considered interface specific or should they be global? And nobody's going to help me answer that. Are you okay with changing the direction of the reference? Because it matches more closely with what you described, Julius. Okay. So the other question
Let it
then
be
gets-
noted that Julius nodded.
Yeah, thank you. Julius nodded. Okay. And it was not nodding off. That was an actual responsive nod. Yeah.
Okay, Julius Krabacek. The question here is whether an security credential refers to an interface or an interface refers to a credential.
Or a group of credentials.
Right now
Yeah.
there is a disagreement between my implementation and the information model, and we are trying to work out whether I'm wrong and Barbara is right, or whether Barbara's... I got confused.
No, we're not trying to
there
do
can be-
that.
There can be only one. We should agree on the direction of the reference in one way or the other.
And everybody is saying that we should reference from the interface to this set of credentials.
That is what I support, yes.
And that's what, good. That's what you nodded about, and I agree with you completely, and that's what my colleagues at Broadband Forum said too. So it's like everyone agrees that Barbara is wrong. Okay? Okay. But now the other question I really have is about, are these other parameters global, or can they be associated with the set of credentials?
Okay, verification of received packets. That's clearly you want that to be per link. You have a secure router. You're adding a new link. There are insecure routers on this link. You want to transition the new link. You don't want to disable security on all the other links just because you've added a new insecure link.
Okay, so in the HMAC, it can be associated with a set of credentials that the link points to. Or,
I would say it should be associated with the link itself,
With the link.
the interface itself.
okay.
So you have a set of credentials. It's on all of your interfaces. You're adding a new interface, and you're adding this new interface incrementally.
So basically, these parameters
And the-
get
and the
added up
credentials
under the
are the same.
interface.
Yeah,
The
that's where I
parameters
would
go to
put
the
it.
interface for HMAC. Okay,
Yeah, for this specific one you've quoted, which is whether verification of received packets is enabled.
right. Those get added, that goes to the interface. Okay.
Mahesh Chetanandani. I think we should try to answer the question of which interface refers to DTLS HMAC object or the other way around is by asking the question, do you have one interface that refers to multiple DTLS/HMAC objects, or that you can have a given DTLS/HMAC object being used by multiple interfaces? What is the case?
I think a single DTLS can be used by multiple interfaces, and that's highly desirable because we want there to be kind of a default or to be able to use a single for everything.
Then
But the other one that Toke did bring up was it would also be desirable to have a single interface be able to point to multiple objects. And I think we can have both. And for HMAC, it's once we pull this global parameter out, I think we're fine. I now need to, though, understand the DTLS, whether the DTLS things are global or are they link specific. Or you don't look convinced. I'm sorry.
So
We'll talk.
I think it's hard to do that here, but typically you want to have a many-to-many, so an interface can have many something, and this thing should have like a name that you reference it by. This credential, like a SSH key, if you're doing that, or so on, you should have that flexibility because that always comes up sometimes later. I would say that you would want to do something like that.
We'll get to names later. Okay. So if the DTLS people could kind of think about, are these DTLS parameters global or would they be kind of link specific? That would be really helpful. Yeah, they're not going to answer me today, but I want an answer. And if you don't give me an answer, I'm going to make a decision. Okay. Name for DTLS cert and HMAC key. And this is more informative because Mahesh and I have already agreed on this. We're going to be naming these things so that they have a unique key that you can refer to them by because there's really nothing else to refer to them by. You're not going to refer to a key by its value. Okay. Let's see. So we've also taken one step up. This was about the actual certificate and key, but one level down we had these objects, and some of this, where we're trying to figure out how to refer to these HMAC and DTLS objects that contain keys, one or more keys. And Mahesh and I had disagreement on where to specify the unique key because in some of my modeling that I do on the broadband forums side, we have auto-generated things if you don't specify a unique key, so I don't need the information model to do something for me necessarily. And so I think, Mahesh, we kind of agreed that you can just specify something in Yang if we don't do anything here. Does anyone else? Oh, Julius does have something to
And
say.
why not a hash of the content?
Say
And then
what? Oh my God.
Or Even simpler, why not use the key as the identifier itself, a fingerprint or something like that?
So, okay, so that goes back to this one. This is a specific certificate or a specific key.
And that's a human readable name.
User specified.
It can be.
So
It's the information model. At this level, it doesn't care. Once you get into a Yang data model or a broadband forum data model, they do different things, or even if you're doing some other way of data modeling it, those things are going to care, but it's left up to the data modeling mechanism and not dictated by the information model. In this case, we're saying that we do need some sort of name. We're not specifying the syntax of the name, but it cannot be the exact value of the certificate or of the HMAC
So I
key.
think I understand 3. I don't understand 4.
Okay. 4, we're going to need, there is inherent in the information model as currently specified, there is nothing you can point to that is a unique key. And so what I'm saying is we're going to leave it up to the data model to figure out what's the right mechanism within the context of that data model as to how to uniquely identify these entries.
Okay, you'll have to explain that to me offline.
Or over beer. It might make more sense over beer.
Beer is offline, usually.
Okay? I think Mahesh and I are fine, and I'm really more concerned with Mahesh than I am with you, Julius. Okay.
So if you go back, what does unique mean here?
Huh?
Is this unique? Is that this thing can only occur at one point in anywhere, or what does it mean by unique keys?
So when you're looking at a set of objects,
Right.
you need to be able to address the object that you want.
Right.
You know, like if you've got, yeah. And so that's simply what we're saying is how do you address the object that you want? And in all of our other things, you know, like when we've got their interface list, we have a unique way of identifying the interface. We have a unique way of identifying the route according, you know, to the IP prefix and stuff. But when we got to these tables, there was nothing.
Okay.
And so we're leaving it up to the data model. Okay. Metric parameters. Oh yeah. Okay. So this is hope. Oh, Christian, you have something to say. Is it on the last one?
It's Ronald. But
Oh, I'm sorry, Ronald. I'm
Ronald
sorry.
talk. Yeah,
My bad.
I just have to say that I'm failing miserably to capture this discussion because I'm not at all familiar with the information models.
Don't worry about it.
Yeah, don't worry.
I appreciate it. And you don't have to record that either.
So, we're not too short on time yet, but we are, Mahesh is going to get some time. for
I've
different-
only got 2 more issues, and then we're done. And this one should be a quick one. And this is something that kind of came up just in Mahesh and my recent discussion, and so we figured we'd just toss it out here. We have this, the route, the calculated metric and the received metric, and we previously had input that we have to have one of these. But the question that wasn't clear in my mind is, are they mutually exclusive, or is it possible to have both of them?
You really want to have both.
You want to have both.
You really want to have both.
You
No.
you must have one, but it's okay to have both.
For debugging problems, you do want to have both.
You
So
you must have one. Having both is desirable.
that's right.
Perfect. That was quick. Okay. Okay, so, and this is a personal problem. This actually didn't come up with Mahesh. And I just wanted, well, actually it sort of did. I just wanted to be absolutely sure that when we reference an interface, that it can, from our interface list, when we reference some other interface where this interface lies, it can be at any layer, physical layer, MAC layer, IP layer, tunnel, IP. We don't care what layer that interface references. The lack of people coming to the mic means we don't care Thank you. I have my answer. Oh,
I don't understand the issue.
so we have, right now, when I look at the implementations, they're referencing something like ETH, a Linux ETH1,
That's right.
which generally an ETH1 has the full IP stack on it. It's really not the specific Ethernet layer. It's this thing with all of these IP address stacks on it. If we had, say, in Linux, the ability to reference the 100 base T interface, would that make sense? Or are there layers that don't make sense of interfaces?
No, because Babel runs over IPv6,
Okay,
which means that you want to be referencing the layer 3 object.
exactly my
However-
question.
However, and the fact that Babel is using lower layer information, it's very carefully designed, so it's only an optimization. In that we reference the layer 3 object, and if we have access to the layer 1 and 2 thingies, we can use it. But what is fundamental is the layer 3 object.
Okay. And I think that answers my question, because both Yang and Broadband Forum, we basically stack our interfaces. And so you've got, here's an IPv6 interface. And this IPv6 interface, by the way, happens to ride on this MAC interface. And this MAC interface happens to ride on this physical interface. And so your interface stack. But the question is, at what entry point, where in the stack should you be pointing? And you're saying, I need to be pointing to the IPv6.
Quick answer, I need to know the link local IPv6 address.
So we're good.
Yeah.
We're good. I've got my answer. Thank you. And it was not the answer I was going to go for if you hadn't stood at the mic. So it's a really good thing you got up there. So we're in WGLC. Additional review would be really great. In the meantime, we just resolved just about every single one of our issues, I think. So I'm going to be revving the information model based on this, and we'll do the Yang and the TR-181, and I think we're in pretty good shape. Thank you.
Yeah,
See,
that-
told you that wasn't much longer.
Yeah, that's fine. Thank you very much. So there is a working group last call been issued, and there hasn't actually been much response on the mailing list. And there are these issues. So that since the document's going to be read, well, let's continue the working group last call. Next is Mahesh. Actually, I don't want to do that. How do I get out of this thing? This page? Oh, it's that. There we go. Sorry. Yep, and then the magic button.
So Julius, if you were concerned about the number of Z's in your name, we can exchange some A's and Z's together. All right, the status of the document, it is a work group document, as Donald has already verified. We did manage to augment the routing management interface, RFC, which brought us support for addition of RIB. The VRF instance is something that is now available for us to also add. I haven't quite done that as yet, so in the next rev, I'll take care of that. So with the changes, the model now looks something like this. As we say, I'm augmenting the routing 83 RFC 8349. And as Barbara said, we have now HMAC and DTLS support, which we have added to the Yang model. At the bottom is the addition for RIB and RIB support under that. So issues. So much like Barbara, I also have my own GitHub, which is tracking all the issues related to the data model. This discussion I think we have had, so I'm going to kind of skip over this because I think we're going to come back with a proposal on how to really model the link type. So Barbara and I had to go back quite a bit on this discussion of mandatory values. And I finally, after several attempts and a good breakfast, Barbara explained to me that the two attributes that she's trying to address. One is mandatory to implement, which is not what this slide is about. And there's mandatory from a model perspective as far as values that need to be provided for the protocol to work correctly. So I don't have a slide on mandatory to implement, but I'll just say, I'll wave my hands and I'll explain this maybe in the model, is that we need some capability of a feature statement, which allows an implementer to declare what features they support. And an example of that feature would be, I support DTLS capability, or I support HMAC. And once you declare that feature, then the model is expected to have all the capabilities defined. If you don't declare the feature, that part of the model pretty much vanishes, and you don't have to worry about trying to implement that. So that's mandatory to implement. So now, mandatory as far as values that need to be provided. So I think in this particular case, what I've highlighted in red are two parameters, which I believe are mandatory parameters. And what happens is that when you do specify that something is mandatory, when the client tries to configure the router or router with that information, if those values don't exist, the client won't even be able to send that config request to the server. If the client is not good enough, is not doing a good enough job, the server will definitely check and return an error saying you have not specified the mandatory values. It also means that the scope of mandatoriness is limited to the parent. So in this particular case, the two parameters that are highlighted in red are mandatory only if an HMAC is being specified. Of course, if HMAC is not even being specified, then it doesn't matter whether there are other parameters within that are mandatory. The other clarification was around read-only attributes in the information model. In Yang, typically, it doesn't really make much sense to declare something that's read-only mandatory. So something like router or router ID that Babel uses is a read-only attribute, means it's set by the system. So it doesn't make sense from a config perspective to say, well, router ID is mandatory. No. If it is not said, there's nothing that config can do. Anyway.
If I read the router ID, can the answer be there's none?
A proper implementation will make sure that it is always set. But yes, to answer your question, it is possible that if you read and the implementation hasn't done it right, you might actually get nothing back for root right.
I think what Julius is trying to say, David Skenazy, I think what Julius is trying to say is that you can actually have an implementation of Babel that does not have a router ID. That is just a simple client node on the edge that doesn't offer any routes. And so it's valid for that to be non-mandatory.
Okay. Then actually, I don't know, maybe the information model, then what I'm gathering is that it's not mandatory.
Right, which also means you can't use it as a key.
That is true.
I mean, it's not quite that clear. So does it make sense to put restrictions on the implementation? Does the management model put restrictions on, is it legitimate for the management model to put restrictions on the implementation? So it is technically possible not to have a router ID, but it doesn't cost much to say we always have a router ID.
Okay, so let me back up. The reason why Barbara mentioned, well, it can't be a key is because currently we reference an instance of Babel by the router ID. And if the router ID is not there, then we have no way to reference.
Not shocking. But but my question was actually more general, because that's a detail we can bring to the mailing list. Does RO, so RO implies that there is no way of saying it must be present. Is
That is correct.
Okay.
Sorry.
There
there's
are
no way
other
to
ways of
enforce-
saying it,
Yeah.
but in Yang, RO does not imply that. There are other ways.
What I mean to say is that it's not enforceable. I mean, you can have it in the description and you say you must provide, but okay. All right, so we have had discussion of keys on the mailing list, and I don't know where this discussion.
Sorry, just a quick last point on the router ID. I just checked the 6126 BIS, and the spec explicitly says that the router ID must not be either all zeros or all ones. So if this makes your life easier, you could, if it's not there, have it return all zeros, for example.
Well, then the question is, can multiple instances of the routing return zeros, all zeros, in which case then it's not unique again.
True, yeah, but like those instances that don't have a router ID are just going to be kind of observers. They're going to be like almost invisible to the rest of the network. So not being able to refer them is kind of okay.
No, it's not okay.
No, it's not okay, and Julius is shaking his head, so forget what I just said.
They don't appear as originators of routes, but they might appear as neighbors. So you still see them.
So y'all are thinking of this from the network perspective. We're thinking of this from you're inside this box and you need to reference the information. If you need to reference the information, can the router ID be a key into your object model or not? And what we're hearing is not.
I'm glad you're forcing the decision.
No, what we're hearing here is that the natural data structure that is used by Babel says that you only need to have a router ID if you're originating routes. If the data model needs to say that implementations that implement the data model must generate a router ID even though they don't need it just for the routing part, I'm fine with that. It doesn't cost much to generate 64 bits of randomness.
Sure. Okay, so that then answers our question of how we need to update the information model, and I'll reflect that in the Yang model. Thanks for the clarification. Okay, so I'm not a security expert, and I just go based on what is there and some of the data models. So my effort is to try to just bring attention to the fact that there are other data models that we have to deal with as far as setting up keys, key exchanges, and everything related to that. So there is already an RFC for symmetric keys and how to store them and how to use them. There is a draft on the asymmetric key and certificate support that is in the works in the NetConf working group. But none of these, of course, have anything that supports key rotation. I don't know if that's important. If that's important, we need to figure out how we will support that. And then I think this is the question I think Julius brought up on mailing list is how do you share keys across domains as HMAC uses symmetric keys. So I don't know if these are issues, but I'm just keeping it there so that we don't forget it as we try to progress the draft. Either we decide it's not an issue and close them, or we try to come up with answers. No update on the routing policy and augmenting the routing policy model. I'll do that in the next version. And my final issue is with example configurations. I really could use some help here. I would appreciate trying to get some configuration examples that I can use not only to validate the model, but also showcase to people who want to use the model how it can be configured. So if there are different implementations of the model that have different ways to configure, I would imagine that would be very not very kosher. But if it is the case, let me know. But basically, I would appreciate some examples that I can use for validating the data model.
So what you're asking for are examples of real configurations in the current ad hoc configuration language of our different implementations. Is that correct?
That's fine. You give it to me. I'll do the translation of that into what would be accepted by the data model. And then we can validate to make sure that the example makes sense.
Right, so it's mainly wanting real data, but it doesn't have to already be in the Yang syntax.
That's correct. I can do the translation to the Yang syntax.
Including HMAC keys, of course.
Yes, that's what is part of your configuration. All right, that's it.
Okay, thank you very much. This we're actually out of time, so people should help Mahesh getting things he's asking for. You can post something to the list asking for that also, or if you don't, I will maybe when the minutes are done and stuff. So thanks everybody for here. I think we're making great progress. We have a great package of documents already in the publication requested state, and more documents coming along. So see you all on the mailing list, and is Montreal at the next IETF meeting, I think. Anybody have anything else they want to bring up? I guess not. If you did not sign the blue sheets, they're up in front here. Please come and sign them. Thanks again. You're welcome. Yeah. Hi. Okay.
Next session.
Have fun.
I'm trying to be familiar.
Well, so this is the one that's hooked to the projector.
Okay.
I reloaded this agenda.
Okay. Okay. I can just download my slides. Yeah.
Just,
And project.
You can run the slides from that. I guess
It's yours or is